Hi, in this tutorial we are going to solve a question related to NMR spectrum. The question asks, assign the peaks in the following H1 spectrum to the specific hydrogen atoms in the given molecule next to the spectrum. Let's start analyzing the spectrum and the structure of molecule. I will start first analyzing the structure of molecules, and I will identify the different types of protons we have in the molecule. Let's start from the upper part of the molecule. Here we have a primary carbon having 3 hydrogens. And next to primary alkyl carbon, we have here a secondary carbon having 2 hydrogens. And then on the ring we have aromatic hydrogens here and here. They are symmetric, so we expect that they will appear at the same place, or they will be equivalent in the NMR spectrum. And next we have again 2 equivalent hydrogens on these carbons. Then on the last carbon we don't have any proton. Okay, then let's look at the different type of hydrogens, protons, and let's match them in the given spectrum. So here we have 3 equivalent protons, so they are homotopic protons, so they will appear together. And since these 3 hydrogens have a neighboring carbon, and in that neighboring carbon we have 2 equivalent protons, 2 plus 1, so I'm going to label them with letters. So I'll start labeling these hydrogens as A, and A, the hydrogens in A will split into a quartet because these hydrogens having 2 equivalent neighboring hydrogens or protons. So let's write here A will be a triplet. Let's look at next protons. We have here 2 equivalent protons, and let's label them as B, and they will appear in the NMR spectrum as quartet. The reason, because these protons, they are located on this carbon, and the neighboring carbon has 3 equivalent hydrogens, 3 plus 1, n plus 1 rule, so they will appear 3 plus 1, so 4. So they will be quartet. So I'm going to point up as Q, quartet. So B hydrogens, B protons, they will appear as a quartet. Then let's move to ring, aromatic ring. Then let's look at, so we have C, since these are equivalent protons, I'm labeling them as C. Then next ones are D and D, so I'm labeling them as D. So let's look at them. So the proton located at this position, or protons, or C protons, let's say, they will appear as, because each one having 1 neighboring proton, or equivalent, just 1 equivalent proton, so they will appear as doublet. So I'm going to say C doublet, and I will not do the same for this because they appear on the same place. So D, let's look at D. The proton at D has 1 neighboring proton located on the neighboring carbon, so again D is going to appear as doublet. So let's look at let's look at the spectrum, and let's find. We have 1, 2, and here the third set, which is here enlarged. The peaks are enlarged or zoomed, so we can see 1, 2, 3, 4 peaks. So this is a quartet. And let's see, this is another set of peaks, and if we zoom in here, they are actually appearing as a triplet. So this signal is coming from the internal reference tetramethylsilane. Okay, so quartet, triplet. Here looks like doublet and doublet. Okay, so it's very easy for this part because you remember the down field of spectrum around between like 6.5 to 7.5. Generally aromatic protons appear here, so I will say that one of them is D and one of them is C hydrogens. But which one is which? Like as a general rule, if you have a neighboring electronegative element like bromine here, so the closer protons or neighboring protons, they will appear on the downfield spectrum. So I will say that this peak has a doublet, which a relative area here it's 2. So 2 proton, 2 proton, 2 proton, 3 proton. Relative areas are also proportional to number of protons. So this is going to be D, this is going to be C. Then it's very easy here because we have a quartet and triplet. A has to be triplet, so this is triplet, which is this one, A, and B should appear as quartet, which should be this. So basically, in this question, we had an NMR spectrum and we have a chemical structure. First we identify the types of protons and their splitting patterns. Then we match them to the peaks in the given spectrum. Thank you so much for watching this video.